In this video, I'm going to go through the dice distribution feature on Extreme Gammon, or XG. This is an image of the dice distribution feature. Now, what is dice distribution? In backgammon, when you play, you make a move and you want to think about what your opponent will roll next, and based on that, make the best move. And sometimes you want to look even one roll beyond that at what you will roll after that to make your best move. Dice distribution is a feature or a tool on XG that can be used to learn these things and help you understand these things in advance. So, and what it does is it will show you all of the opponent's next 36 rolls and which ones are good and which ones are bad. So I'm going to show you how to do this. We're going to use an example of a second roll position where the opponent rolls an opening 6-4, that's white here, and splits, and then you roll a 5-1. This is one of the most commonly misplayed rolls on the second roll, and this is for a money game. It's not a match, so you can see that here. The correct play is to play 13-7, hitting once. A lot of people, and we'll see what that looks like in a moment. A lot of people incorrectly hit twice, once from 8-7 and once from 6-5. It does put 2 on the bar. However, it fails to bring in another checker into the zone, and it does not unstack the midpoint, and it strips the 8 point. So we're going to look at the dice distribution feature to show exactly why it's better to hit once. This is what it looks like when you hit once. You come here, you're left with a blot here that can be hit with good 6s from the bar. However, now you have 9 checkers in the zone. You still have a spare checker on your 8 point, and you've unstacked the heavy midpoint. So you can attack and make plays like making your 5 point really easily. For example, if you roll a 3-1 next, you can make the 5 point without breaking your 8 point. So that's hitting once. This is what it looks like if you hit twice. This checker remains here, and instead you hit once from 8-7, leaving a blot here and stripping the 8 point. And the second one you hit from 6-1, it does have the benefit of unstacking the heavy 6 point, which is harder to unstack than the midpoint because it cannot be played with 6s like you can from the midpoint. However, it does place the checker in the deepest point in the board, which is not the best place for it, and it gives the opponent good ones. That's 11 good numbers directly from the bar. So this is what that looks like. Now, if you wanted to make the 5 point next with the 3-1, you could do that, but then you'd be leaving a blot here on your 8 point, as well as one here on the ace point. Now, when you want to see the dice distribution feature, you look at the multiple plays. So you put in a position and then you push the plus button and it shows the plays here, and you highlight the 2 plays you want to look at, and then you right click it. When you right click it, you will see this menu, and you're going to want to go to dice distribution and click on that. And this is what you see. There are different tabs here. There's details, graph, distribution, dice map. I find the dice map to be the most useful for me, but there are other features that can be used, and that may be a topic for a different video. What you want to do is hit the icon with the most red bars. This is the 5 red bars. I believe that's 4 ply. And when you do that, you'll get the most accurate data. Now, what you see is a 6x6 grid on either side for the 2 plays. So the one on the left is for the top play, 13-7, hitting once, and the one on the right is for the second play, hitting twice, 8-7, 6-1. And these are all the different rolls by the opponent on her next roll. So for example, this would be 1-1, this is 2-1, this is 3-1, and so forth. And then going down, this is 1-1, 2-1, 3-1, and so forth. So you have 1-1 to 6-6, and on the far right is an average. So this cell is an average of all the ones. The second one is the average of all the 2s, and so forth. Now these are color coded, so it goes from green to red, and yellow is in the middle. And the color coding is not ideal, in my opinion, when you have two graphs side by side, because you see the highest value is the brightest green. Here in this one, it's 0.343. The lowest value is the darkest red, which is negative 0.309. Okay, so everything in between, any value in the middle about 0 will be about yellow. So that's the case here where it's plus 0.001, which is yellow. However, on this chart here, the scale is different because the highest value is still about the same at plus 0.344. However, the lowest value is minus 0.634, which is over 300 less than the lowest value here. So the middle value is going to be closer to, minus 0.1 or something like that, 0.15. And that's going to be closer to minus 0.89. You see how this is the yellow. So because of that, I've designed something so it puts them on the same scale. Now, that being said, if you want to just look at this, you can see how these play. So, for example, double 6 is really good for you after either of them, and that's why it's the brightest green, because white would dance. Now, this is the one that I've designed. It takes a little bit of work. It's a separate Excel file where you have to import the data from XG into Excel, and then it processes it, and then you get this. So instead of having the two separate ones on a different scale, these top two are on the same scale. So the darkest green is the highest value on either chart. So that's 0.343 or 0.344. They're about equal. That's the darkest green. The darkest red is the lowest value on either of them. So here it's minus 0.634. So that's the darkest red. Now notice that this was the lowest value, minus 0.309 on the left-hand graph. And that was the darkest red on the XG one, but here it's not so dark. The other difference is here, the middle is white instead of yellow. I just find that's easier to see on my eyes. So this makes things easier to see. So you look at how many dark reds you have here, all of these ones, the double 1s, double 2s, double 3s, double 4s, and double 5s. Whereas here, they're not great, but not quite as bad as in here. Now, the difference heat map, what this does is it takes a value, it subtracts the values from these two. So for example, after the 1-1, your equity after play A, which was 13.7, is minus 0.249. After hitting twice, it's minus 0.634. So when you take this value and subtract this value from it, minus 0.249 minus negative 0.634, you get a value of plus 0.385. So these are all the differences. So in this one, this is a big swing from in favor of the first play, 385. So all the positive values are green, all the negative values are red, and the color coding is the same. The highest value is green, the darkest green, the lowest value is the darkest red, and then everything in between. So now this shows you any of the ones are better had you made the first play of hitting once, because if you hit twice, white has good aces from the bar. So any ace that, basically any ace she rolls is really good for her, and that's why it's bad for you. Now, this can be shown in a histogram format. So if you look at this one, the highest value is it's 0.378 is the highest difference. However, because that's a doublet, it only counts once. The highest of the non-doublets is 0.352, so that value is doubled. So 5-1 is the biggest swing. And then in the other direction, 6-5 is the biggest swing the other way. So this allows you to see it in a histogram format and this a color coding. Now, this table shows you exactly how the opponent's rolls are played. So remember, the 5-1 was the highest one here, so that's at the top over here. And you can see that equity difference here on the right. There's the most green, there's the bar, and there's the actual number, and it's color-coded darkest green to darkest red. You see, in all of these, when white rolls a 5-1, 2-1, 3-1, 4-1, double one, she's going to be coming in from the bar with bar 24. And then in the case of double ones, bar 24, and then 24, 23. However, in the other situation, had you hit twice with 13, 8, 7, and 6, 1, all the entering aces, the bar 24 would be hitting. So that's why you see the stars. So those are big negative swings in the case of hitting twice here. That's why they're in favor of the green, which is the top play. And at the other end, you can see all the other ones. For example, the sixes, she has good sixes from the bar. For example, if she enters with 6-5, 6-4, 6-2, or 6-3, and even 6-1, she's able to enter with the non-6 number and then hit with a 6 number. So these are all negative swings, and these are all positive swings. However, there are more positive swings than negative swings. That's why hitting once comes out on top. The other thing you want to think about is not only the opponent's next roll, but your roll after that. So I've designed another feature in this Excel spreadsheet that will show that. This is not included in XG. You have to extract the data and put it in there. So this is the second roll. So this is on black's roll after that. So 3-1 is the biggest swing. And that's the one that I mentioned, because 3-1, you're able to make your 5-point without breaking your 8-point after hitting once, but not after hitting twice. I'm going to show you that here. So this is what it looks like after hitting once. If you roll a 3-1 after this, you can make the 5-point 8-5, 6-5. However, had you hit twice here and here, and you played a 3-1, you could still make your 5-point, but now you're breaking your 8-point and leaving a blot on the 8-point, a blot on the bar point, and a blot on the ace point. That's really bad. So that's why this is a big swing in favor of the top play. So in this dice distribution feature, the special one, you're able to see 2 rolls in advance. And that's basically what you want to do in any play in backgammon. You want to make your play so that your opponent's rolls play bad or poorly, and your rolls after that play better. And that's what happens here. So that's the dice distribution feature. It's one of the most valuable tools, in my opinion, on XG, what I use the most. And it's a really good learning tool for me and for other players. And sometimes people say, a common question is, how is that useful when I'm in the middle of the game? Well, it's not useful while you're playing the game. Instead, it's useful to look at after you play, so that you learn to think about these things and you're able to do it yourself in your head when you're playing the next time. So it's a learning tool for the future. It's not for while you're playing, of course. Anyway, that's the dice distribution feature. It's a great tool. I hope you enjoyed it. I hope you learned, and I look forward to seeing you next time.